Good afternoon, YouTube. This is Nick Herring from Red Label Productions, here again to present the second in our series of short pre-recorded webinars covering audio topics for event professionals. In today's video, we'll be covering the second part in our wireless systems for event professionals series. So let's get into this. So in today's presentation, I'll be covering some best practices and my general workflow for frequency coordination, utilizing both RF Explorer and Shure's wireless Workbench. I'm going to go over how I use both together, and I'm going to do my best to cover how I use each system independently. So before we really get going and get into the coordination process, I really just want to take a second and review some of the best practices. I showed this slide in the previous webinar, and we talked about it a little bit, but there's just a couple key points that I just want to double down on. Your setup here when you're deploying your system. This is where most of your issues are going to arise. So this is where we really want to make sure we nail down this part of the process, so we're not creating more headaches for us down the road than we really need to. So the first thing I want to point out here is we're looking at this illustration. You notice we've got front of house back in the back of the room there, and we've got a pair of fins that have been remoted up to the front of the stage here. Looking at it from here, we've got a direct line of sight. There's nothing in between the transmitter and the receiver antennas. This is all great. We notice that they aren't symmetrical lengths of cable, and that's absolutely a-okay. That's not something that we need to worry about while we're setting these systems up. So while we're looking at this, this is definitely something, an idea for things that we want to emulate and take with us while we set up our systems. Of course, this isn't a one size fits all. Of course, there's going to be challenges unique to each deployment in each venue and each setting. And we're going to have to do our best to work around this, but this is a great starting point and to give ourselves a good idea of what we should be working with while we get started here. So now let's get in and talk about frequency coordination a little bit and what this process is. So frequency coordination is the process of scanning, selecting, and deploying the best frequencies to use for your wireless systems. This process allows you to take into account interference from existing broadcast and radio systems that may be in your facility, maybe in your venue or close by. We're taking into, we deal a lot with broadcast television stations, and we'll talk about that in depth once we get into the analyzers and we start looking at that and some of those other screenshots here. And then the other part of this too is that we want to make sure that whichever channels we select, we're not going to allow ourselves to create problems with intermodulation. We talked about intermodulation in the previous video, but just to touch on that, intermodulation is when we've got two transmitters that are close frequencies that are placed physically close to each other. What's going to happen is that the RF is going to interact with each other, and it's going to create spurious waves, spurious signals, which is going to create headaches for you while you try to coordinate and deploy your system. So a big part of wireless Workbench and why we use that is there's a calculator in there which allows us to select frequencies which aren't going to interact with each other as much. So that's something that we'll touch on once we get into that. So one of the primary tools for frequency coordination is the spectrum analyzer. And analyzers take many different shapes and sizes, ranging from simple software options, stuff like WinRadio, to handheld and rack mount options. I've got the RF Explorer here pictured, Shure's Axient, their analyzer, their rack mount analyzer, that's pictured as well. And then we've got all the way up to full-blown lab quality bench rigs. These are going to be much higher resolution than your handheld analyzers. These are going to be much quicker. You're going to be able to see a lot of things like, if you're in the correct spectrum space, you can see things like cell phones pinging towers and that kind of stuff. We don't need any of that for our applications with this. If you were designing and building wireless systems, this is absolutely something that you would want to invest in. For our purposes and for most deployment situations, this isn't really something that we need to touch on. For my process, as I mentioned before, I use both, generally speaking, 9 times out of 10, I use both the handheld RF Explorer and then wireless Workbench, and I'll do a scan with both the RF Explorer and then using one of the receivers in my wireless system as well, assuming I'm using a Shure receiver that can be networked. And so we'll touch on that process again, as I mentioned a little bit later on. First and foremost, before we get into this, I'm not a radio engineer, nor do I claim to be. I'm an audio engineer first and foremost. The process that I'm going to outline are the steps that I take most frequently. And I feel like we're going to do a good job of hitting what's important. Of course, there are things that we can add if we're in a higher profile, higher stakes gig. And there's things that we can take out if time doesn't permit or we're in a rush. But we definitely want to, this is the kind of thing where an ounce of prevention is worth a pound of cure, is worth more than a pound of cure. We want to really make sure that we're taking the steps and making sure that we've got good quality RF links before we, as we're deploying this wireless system. These are an improvement on using the built-in scans in your receivers. I see a lot of people do that. I see a lot of people when they deploy systems don't do that. So I mean, just by taking that one step, I mean, we're doing more than 80% of the users out there. So I mean, that's definitely something that we want to keep in mind as well. So let's take a quick look at the software here. Here's the screenshots of two of the programs that we'll be using. I've got both Wireless Workbench and RF Explorer. We'll be getting into these a little bit more in depth here in a couple minutes. And then here's just a quick illustration of what our setup's going to be. So as we walk through this, our setup for the illustration today, unfortunately, I don't have a camera with me, so we're not going to be able to see the setup itself. We'll be working with screenshots from the software as we do this. But I've got 4 QLXD receivers, mic systems that we're going to be coordinating. Those have, as I mentioned in the previous webinar, those have a networking capability. So we're going to be using some of that within Wireless Workbench. You see we've got a nice little Ethernet switch there, which is going to be connecting the QLX systems with the laptop. The RF Explorer, that's going to be coming into the laptop to use with that program via USB. So that's something that we've got. I'm also going to have a pair of Shure PSM 300 in-ear systems. I wanted to use these and coordinate these because those, if you're not familiar with that product, it does not have any networking abilities. And so we're going to be able to use these to show how we can continue to coordinate frequencies within Wireless Workbench, even though it doesn't necessarily have a networking, it doesn't have the device doesn't have networking ability. So say we're using, just because we're using Shure Wireless Workbench, we can use that in our coordination efforts when we're using Sennheiser, Lectrosonics, AKG, Audio-Technica, you name it, whichever other manufacturer. The last thing I just want to point out here, there is a Cat5 cable running between the Ethernet switch and the console. That is purely for control. The QLX systems do have Dante, and I could set up a Dante network. I do have a Dante card in this console. Just for my purposes, 9 times out of 10, I'm using a TO box, and we're just using quick config. So I'm not, I didn't feel the need to open up your Dante manager. So I've got the audio outputs just running over regular XLR cables. And so that Cat5 cable between the console and the switch there, just for console control, if we need it. That's just how I happen to have this rack wired up. So the next step here is we're going to turn off our transmitters, and we're going to get into RF Explorer. We're going to start that process here. All right, so here we are in RF Explorer, and I want to just take a second and point out a couple of the main features of this screen here. So this is the main spectrum analyzer screen when we first get in here, and here's a couple of things that, obviously the two most important things that we look at are, here's our analyzer window right here. We've got frequency over amplitude, and then we've also got a time spectrograph as well. RF Explorer is nice in that as we run this and we do live traces, we're actually able to go back through, and if we want to look at a single trace here, we can go back through, hit hold, go check out that trace. For example, so if we, say a system gets turned on intermittently, or something along those lines, this is super useful in letting us see that. So I'm going to go ahead and let this run. I froze this analyzer here before we started recording. I'm actually recording with wireless right now. So once we start running here, we're going to see that channel pop up. So let me go ahead and get that going now. And so we're running here, and there we go. And you see there's me, and we're super close together. So we may be having some issues here. And we're, I'm probably 6 feet or so away from the receive antennas right now. So we definitely have, some intermodulation and some noise and a lot of that kind of wonkiness going on. But in terms of our coordination, if this were, if we weren't recording this, we were doing this as an actual coordination, you would want to turn off all of your transmitters right now, get all of this noise out of here, just so you can see what's going on. Other features that I want to call out in this window here, you've got your frequency span here. So as I mentioned earlier, we're going to be coordinating 4 QLXD systems. I believe they're the G50 band, and then a pair of PSM 300s. Those are the H50 bands. So as you see our bandwidth here, we start at 470 and we go all the way up to 542.999. So that's the range that we're working with here. Last thing I want to point out in this window, just looking at this time spectrograph here, this is super, super handy if you've got a situation where, say, during your show, during your event, a comm system gets turned on and off, or there happens to be another wireless system in the facility and you're competing with that frequency space. This is going to allow you to see over time, over the history, whether or not things are coming through. So as we're looking at it right now, if you look at my mouse here, we'll get the circle going. You'll see there's some intermittent noise right here. Some of that, that may be intermodulation effects, that may be something else. But we see that. So if we were in here and we were setting this up and coordinating, say I didn't know what this was, I didn't have any transmitters on right now, I would know that we would want to avoid that space. Probably keep most of our coordination efforts in here. Within RF Explorer, a couple other things I want to point out. We do have a waterfall view, which is also handy for real-time monitoring, watching issues develop over time. You see there's me. That's another TV station here. I believe that's channel 14 or 15 here in Washington, D.C., so it's probably Univision, if I remember correctly. Neither here nor there. This is just a handy view for monitoring during your event. If you have the luxury of just watching RF, of just doing RF coordination, you're able to devote the energy and watch this and make sure nothing else is going on. You've got a couple other channels in here, a couple other screens in here. I generally don't use, just because in my analysis, generally speaking, what I'm going to do with RF Explorer is I'm going to take a peek, see what's out there, see what's going on. Adjust my bandwidth to the bands of whichever systems I'm using, and then we'll go into what I really use RF Explorer for. Let me just pause this here, so we'll hold, and you'll see the traces stop moving. What I really use this for is to take this trace and export into Wireless Workbench, and I'll talk about why in a minute here once we get over there. But let's just pull this out real quick. So, to export your traces, so you'll go through, you'll run. Actually, before we get into that, let me just mention quick. You do have a handful of trace modes. You've got real time. You've got an average, which is a mathematical average. You've got max hold. You've got a couple different options to fill your lines, to fill your traces, all of that. Really, it's just a preference of whatever you prefer viewing. Because of how I generally use this, because I'm pulling traces out and going into Wireless Workbench, I'm going to load a trace into Wireless Workbench. Generally speaking, I'm going to be working with averages. I find that's going to be the most useful for me in what I do. So once we do that, we select average. We go here to file, and then we've got a couple options to export CSVs. And so what this is this allows us to basically take this graph and export a set of plots, which we can then dump into Excel or Wireless Workbench, or if we're using another coordination application, IAS, Clearwaves, Wireless Workbench, whatever. This is how we pull the data from this radio here, and then use it in that application. So your two options here, you've got export single CSV, which is what we're going to use 9 times out of 10. This is what most programs are going to be looking for. Basically, what this is going to do is this is just exporting coordinates for this single trace, whatever's being displayed on screen right now. Very important to note that it's, if you want to use real-time reading, we're going to do that. And if I select that, that's what's going to be sent out. If I use average, that's what's going to be sent out. Cumulative CSV is the complete set of data, everything that we've read. This is much more complex than what we need it. This is going to be, if you're going to do more complex RF engineering, that kind of stuff, that's really where you would be using that feature set. For simple coordination in this kind of setting, we really don't need to do that. So with that, I'm going to go ahead and get this exported, and let's hop over into Wireless Workbench. So here we are in Shure's Wireless Workbench. Wireless Workbench is Shure's monitoring and coordination software, and has a number of features which complement RF Explorer nicely. RF Explorer is great because it gives us real-time monitoring and a wider bandwidth of spectrum analysis. We'll talk about that in a second. The biggest reason being because frequency sweeps are limited in Wireless Workbench by the hardware we're using. We're limited by the bandwidth of the receiver that we actually have networked here. I'll show you in a second what I'm talking about. But RF Explorer gives us a little bit more visibility. We're able to take the traces that we pull out of RF Explorer, pull them into Wireless Workbench, and then really do, allow us to do some pretty nifty things with our coordination here. But let's get into this first screen here. So generally speaking, when you open up Wireless Workbench, this is the first screen that you see. On this inventory tab here, basically these are the devices that we're going to be coordinating. As I had mentioned in the previous webinar, I use Shure QLXD, which has networking capabilities built into it. Basically, with this, if you recall back to the sides, we've got our 4 QLXD. We're running Cat 6 to an Ethernet switch, another Cat 6 cable coming out of that switch into the network adapter on my laptop here, which is where we're pulling this up. If you've got everything hooked together and nothing comes up, there's a good chance you may be using the wrong network adapter. Just go here to the bottom right hand corner. We'll see 4 devices online. We click on that, and then this window gives us the option to select which adapter we're going to use. We've got some Wi-Fi options. We've got our Ethernet jack right there. When you make your selection, you hit apply, save. That'll pull you over to the correct one. Now, I had mentioned before that Wireless Workbench gives us the options to coordinate for devices that are either A, not networked, or B, not even Shure. So in this situation, in this example, we recalled, we're going to do four channels of QLXD and a pair of PSM 300s. So because the PSM 300s don't have any networking options on them, we have to go up here to the top left-hand corner, select Add New Device, and we've got to manually input the devices that we want to coordinate here. So in this case, it's a Shure. Our model is PSM 300, and the band is H20. Boom. And I've got a pair of those. So we're going to go to 2 and then hit add. If we want to add anything else, we can add all sorts of different manufacturers: EV, Audio-Technica, AKG, Electrosonics. We've got some comm systems from Telex. Basically any kind of coordination you would need to do, we would want to handle it within this program. Now, as I mentioned, there are other pieces of software we can use, Clearwaves, whatever. This is really because in my personal workflow, because I primarily use Shure. I've used Shure most of my career. I'd mentioned before, somewhere in the neighborhood of 80% of the deployments I've done over the course of my career have been Shure wireless. I just talk relative to those terms, just relative to that brand, just because that's what I know the best. They make a lot of tools that really make it easy for us. So with that, on this inventory page, we've added everything that we're going to coordinate. As we see, we've got a couple other options. If we wanted to add things to monitor, we've got the Shure offers networked chargers and that kind of stuff we could monitor from. All of that would show up here. Here's where we would add it in. So now we're going to hop over here to our frequency coordination tab. As you'll see, normally when you open this up, this is a blank screen. I pulled in a scan before we started recording because I am on a wireless channel right now. So this is a pre-recorded, this is a trace that we did automatically. Now here's what I'm going to do. Let me go ahead and run a scan in real time just so you guys can see that process, just get an idea of how long it takes while I continue to talk here. So over here, we select our scan sources, which receiver we want to use. As we see, this is the spectrum. This green bar represents how much we're actually scanning. So that actually represents the bandwidth of what we're trying to use here. Now, as I had mentioned before, we do not have, I'm using different bands, the QLX bands and the PSM 300 bands. They overlap a little bit, but there's a little space on the top of the PSM 300 systems that isn't actually covered with the QLX system. So that's why I'm bringing in RF Explorer into this system here. And I'll show how we do that in a second here. But so we've selected this. We're going to scan with one source. We're going to do one sweep. Go ahead and hit scan, and it's going to start doing its thing. As we see here, it's kind of difficult to see them overlap. Let me get this first one out of the way. Here's the new trace that's coming through. So while that's doing its thing here, let's move over to our frequencies. Well, that's gonna keep spinning here. So we're gonna add frequencies. Select frequencies from inventory. That's our inventory tab, what we were working on before. I've got everything in there that I'm going to use. So all frequencies from inventory, bring it in. So now we see we've got a bunch of gear here. So we've got 4 channels of QLX. We've got 4 channels of a pair of PSM 300. We're going to let this sit and spin for a second. We can actually see, here's where I was mentioning G50 band. Here's our H20 band. And then I'm going to show in a second here when we pull in the trace from RF Explorer here, we'll have those overlap. And so let me go ahead and do this now while this is spinning. We'll see if we can make the computer freak out. We'll go import from file. This is webinar 42420. Go ahead and open this up. There we go. Perfect. And so we see here is the imported scan data, and we see that they don't really line up directly. The trace from the Shure system is a little bit higher resolution. I say a little bit; it's significantly higher resolution. We get some discrepancies too in terms of our levels. We've got this nice overlap here, channel 15 that I had mentioned. We've got some exclusions here as well. And so if we see in our additional exclusions, this channel 15 here would be excluded under both traces. This red line here is our exclusion line. We see that there's some other stuff that we're going to be, there's a lot of other stuff that we would exclude based on what we were pulling from the RF Explorer and not based on what we're pulling from the receiver itself. For me personally, to conceptualize this, is either one necessarily right? No, not necessarily. And there's a lot of things that go into, a lot of factors at play here in terms of what's actually reading out. This is one snapshot, which is an average of cumulative data, for who knows how long we recorded our sample for. What I would say is if I've got this space and I can afford to be more selective and I don't have to use all this frequency space and I can get do with everything else that's here, cool, do it. Perfect. Yeah. You want to, when you're selecting frequencies, you want to use channels with the least amount of interference on there. That being said, you get into bigger cities, you get into New York, DC, Miami. I haven't done any coordination in Miami, but from what I hear, Miami and Houston are supposed to be especially bad, with the, 600 megahertz auction and everything that's reshuffling with that, very congested frequency spaces. If you're in a situation like that, you may not have your ideal in your first or second or even third pick. And so really it's just kind of, you get in and you triage and you make do with what you have. But in a best case scenario, we can afford to be a little bit more selective here. So let me get this out of here, get the RF Explorer trace. All right, so we've got that. There's me. Let me go back to this first trace here, and we see that big peak disappears. So we're going to use that. I'm going to use the webinar trace, and you'll see here G50 band stops right at about, what is that, 534 megahertz. H20, the in-ears go up above that, so that's where we need this webinar trace to go. Cool. So bottom right-hand corner here, we go over to Spectrum. We've got our live scan. We've got our imported scan. We are going to go here to TV channels and select that. And then currently my zip code is 22207, so I'm going to select that. We're only going to select high power TV stations. I'm inside right now. If we were doing this for real, all things considered, I would say that, I'm currently inside. This is what we're going to do. The biggest thing that I want to note, and why the fact that I'm inside is important, with these TV stations here. Let me pull this up. So we're going to search this. We found 24 TV stations. 19 of them are high powered. We're going to go ahead and save that in. And then the red here, these are published TV stations. Let me get the additional exclusions out of the way here so that we can get a little bit of a better idea of what's going on. Here's what I want to say about this. So these TV stations, they are recorded in an FCC database. Right now, and this video is being recorded in April of 2020, there's a lot of shuffling going around in terms of which frequencies TV stations are broadcasting on, because of the 600 megahertz auction. If you're unfamiliar with that, it's definitely worth doing a little bit of Googling. You'll see that the 600 to 700 megahertz frequency space previously had been used for all sorts of professional and consumer devices, unlicensed devices, wireless microphones, that kind of stuff. T-Mobile had actually recently purchased that frequency space, and that's where 5G now lives, for 5G for T-Mobile at least. It lives in that frequency space. Because of that, all of these TV channels are moving around. We see here we've got 1, 2, 3, 4, 5, 6, and a little bit, maybe 7 channels here, which are in the FCC database, currently being used within 50 miles of my current location here. Based on our scan, it looks like really maybe one of those channels is being used. So per the FCC, per FCC guidelines, I can actually, if we need to, and this is, this goes back to my previous comment about, we've got these exclusions, we see the space that we've got is getting smaller and smaller. Basically, if there's a color over it now, we shouldn't be using it. As we get more and more selective, our space gets, we're competing for less and less space. And let's say, we throw a couple other systems in here. Here's a walkie-talkie system that the building security is using. Here's a wireless system from a neighboring building or whatever. We find that we're looking for less and less space here. So with these TV channels, we see this one right here. Channel 15 is really the only one that's being in use right now. If needed, we can actually broadcast on these other channels, assuming they measure below, and I don't know the exact number, I believe it's 85 dBm, which is where my exclusion is set currently. It may actually be a little bit higher than that. Don't quote me on this. But legally, we're allowed to broadcast on those channels if we need to. Best case scenario, we don't. Let's try to avoid it if we can. But, things happen. As it looks right now, I did these are what I've got over here. You'll see these little white flags. It looks like this was a coordination that I did previously. Here's everything that's saved on those channels. Actually, these don't have anything because it's not reading. However, this is going to go ahead and take a look at this. So we've gone in, added our TV channels. We're able to go through. Let's go ahead and see what we can find here. So I'm going to go ahead and analyze. And we did that, and I was able to find 4 channels for our wireless, but I wasn't able to find any channels for our PSM 300. So let's try that again. We calculate. I've got, perfect. So now I've got 4 channels here, which is good. I've got a pair of channels here. And then the next thing that we need to do from this point forward is we're going to hit assign and deploy. I'm not actually going to do this because once we do so, I'm going to lose my narration here. But I just want to show this window before we do that. So from here, we go through, we monitor, we see here's the channels that we've got. Shure has their little ranking system of how robust we are. As you see, we've got a lot of noise. This ranking system is based on what the existing noise on that channel is. And a handful of other factors, but I mean, really, 3 stars is the best. 1 star, 2 stars is good, but not as ideal. 1 star is okay, is fine. So with this, we see we were able to find a single 2-star frequency. Everything else is 1 stars. That's fine. We should be okay. From here, what we're going to do is we hit auto assign. This is going to select which actual devices we're going to go to. And then for the network devices, we can hit deploy to inventory. The LEDs on the front of the panel are going to flash, and then all of the channels are auto assigned to are going to be deployed to your receivers. From that point, what you would do in this situation, I'm going to talk relative to QLX, ULX, Axion. I mean, in fact, I think even I think there's IR syncs on everything all the way down to BLX. So I think across Shure's full product line, there's an IR sync on every device, if I remember correctly. But basically what, from there, once we've got the receivers tuned to the correct channels, with a Shure system, you hit sync, make sure you hold the little IR window in front of the receiver, the IR window on the receiver, you line those up. It'll flash on the QLXs. It flashes good. Just double check, make sure you're showing the same channel on your transmitter and your receiver. Everything's hunky-dory. You're ready to roll. So that's the basics of how this works here. Next thing we're going to get into is how to monitor. So let me go ahead and get into our monitoring tab, and we'll be right back. All right, so here we are in the monitor tab in Wireless Workbench. Really the only thing that I want to show here is now that we've done our coordination, we've done our deployment, we hit deploy to devices. All of the channels have been assigned on the devices themselves. Now the show's up and running. From this point, as I mentioned, if this is an ideal gig where I'm just doing RF, I'm not mixing, I'm not doing lights, I'm not doing anything else, I'm just doing frequency coordination, and I have the opportunity to sit and monitor, this is the screen that I'm going to be working from most of the time. Now, that being said, I typically will bounce back and forth between this screen, the Wireless Workbench monitoring screen, and then the RF Explorer monitoring screen. The reason being is that this screen right here is just showing me the network devices. So as we can see, I'm using one channel right now. This is me. I've got my timeline here. So I've got an RF timeline, so you can see nice, good RF signal here. We've got an audio timeline, so we can see we're passing audio. Everything's looking good. And then this is actually battery life timeline as well, in terms of our battery percentage. And we see we've got 4 instances of it. Here's our 4 channels of transmitters. Unfortunately, with the PSM 300 channels, those are not networked. We're unable to monitor those. It's just the way it goes. Other stuff I've got on here, we can see which channel we're on. We were mentioning diversity receivers in the last video. We can watch these 2 flick back and forth. Here's our antennas. So there's that. Here's the transmitter type. I'm using a little QLX belt pack. I'm on high gain. Probably don't need to be, just given how close I am, whatever. And then here's some receiver gain as well. If we're using an Axion system, a more advanced system, and we're using a show link, from this, then we get into all sorts of crazy stuff where we can go in real time and say that there happens to be interference on a channel here, and it just happens to be in the hand of the speaker. There's not going to be an opportunity for a stagehand to run up and swap mics out. What we would end up doing in that situation is we would have to swap out remotely using that show link. That's a feature that's available on the higher end Axion systems. That's very rare that you're going to come across that unless you're doing RF for like the president or Beyonce or whatever, something super, super high profile. So with that, this is really just kind of where I'm hanging out, where I'm monitoring over the course of the show. But that's really, really all I wanted to call out with this. All right. And so this has been an abridged version of my coordination and deployment techniques. As I mentioned before, this isn't the end all and be all for coordination. And there's going to be times where we may skip a couple steps, or I may add a couple steps, either due to time or resources, or the profile of the gig. At any rate, I hope that you found this helpful, and I encourage you to reach out if you have any questions. You can reach me at nick@redlabelproductions.com with any questions, or if you want to see how Red Label can help with your next wireless project. So with that, we hope you've had fun, and we'll be in touch soon.